Thank you. Thank you
Go
so
ahead,
much.
Reza.
Thank you, Farouk, for providing us the opportunity of introducing ourselves to Dr. Seck. And thank you, Dr. Seck, for being with us today and giving us the opportunity of knowing more about your research and what's going on in AMTRACK. And we really appreciate that. Welcome to Aerospace and Mechanical Engineering Graduate Student Community Fall 2020 Seminar Series. And today we are hosting Dr. Mamadou Seck from AMTRACK. And the GSC leadership team for academic year of 2020 is this. Roshan and Rodney are the co-chairs. Raj Mohan, Tarun, and Rachel and I are taking care of publicity. Our support teams are Anirban, Emmanuel, and Megnat. And Robert is taking care of the correspondence. And Farouk is our faculty advisor and our mentor. And we are having weekly meetings to organize the seminars for both this semester and next semester. So you are very welcome to join us. If you want, you can contact Rodney and Roshan. And then if you want to invite a scientist to talk about their research, if you are interested in any particular scientist, we can talk about that through meetings. If you want to organize any social events, we can do that. You are very welcome to join our weekly meetings. And it's on Friday, 4 p.m. And if you want to become a GS member, you're very welcome. You can scan this QR code right now. So I will be waiting here for a couple of seconds. You can just scan the code or click on this link. And I think Farouk has shared the slide, so you can click on this link as well. But just scanning this QR code is easier. So you will log in with your OYO ID and just click join, and that's it. And joining us, you can be part of GSC. You can organize the seminars and invite your favorite scientist to our seminar series. And here is we have a Facebook page, and we have just created a GSC YouTube channel that we are uploading the recordings of the webinars on the YouTube channel. And also you will be finding information about upcoming events, all the social events and updates about the university, about the GSC, about AME on this Facebook page. So please follow us. And we'll be having upcoming events in Wednesday, November 11. Dr. Pretson Larson from OU Electron Microscopy Lab will be talking about characterization techniques at OU Electron Microscopy Laboratory. On Thursday, the week after, on Thursday, November 19, Dr. Mohammed Hassan from Cairo University, Egypt, will be talking about optical and thermal enhancement of concentrating solar collectors. So please join us in these two events. The information will be posted on Facebook page. And today we are hosting Dr. Mamadou Seck. He will be talking about analytics for digital transformation of a passenger railroad. Dr. Seck is the Director of Operation Research at AMTRAK, which is a passenger railroad services that provides medium and long distance intercity service in the contiguous of United States and 9 Canadian cities. Dr. Seck's team is focused on improving the efficiency and the performance of the railroad through the application of data science, simulation, and optimization. Before joining Amtrak, Dr. Seck was an assistant professor at the Old Dominion University, Virginia, before 2013 and 2018. And before ODU, he was an assistant professor at Delft University of Technology in Netherlands, Europe, from 2008 to 2013. During these years, Dr. Seck was also very active in consulting and helping different businesses. Between 2011 and 2018, he was the scientific advisor for the Macomi Corporation in Netherlands, providing industries with simulation-based decision support and predictive analytics. He earned his Ph.D. in systems science from the University of Marseille in France in 2007. His research interests are including modeling, optimization, simulation, and systems engineering. So that, please join me to welcome Dr. Mamadou Seck to give his talk.
All right. Thank you very much, Reza, for this nice introduction. It's my pleasure to present to the GSC community today. Let me see. So how do I share my screen here? Here. All right. So can you see my screen right now?
Yes.
Yes, very good. All right. So as I said, thank you very much for this opportunity. For the past 2 years, I deserted the academic field, so it's a pleasure for me to come back and speak to an academic audience. So my presentation here, doesn't really have a framework. I spend a few slides talking about Amtrak, what's the business about, and then talk about what we do in the operations research group, and then just through a few examples, I try to show, what's the content of our work. And then I think the most interesting part, what I look most forward, is just the open conversation where we can get into other topics if needed. All right. So I will start, and please feel free to interject any comments or questions as I go through the presentation. All right. So I'll start with a corporate background very briefly. So Amtrak is actually celebrating its 50th anniversary this year, as it was created by the US Congress in the 1970s, in a context where many private railroads in the US, were operating both freight and passenger service, but generally the passenger service was suffering financially because of the competition from road transportation and from the airline industry. And to save passenger railroad, Congress decided that all these private railroad companies could take their passenger transportation assets and put them together in one company, one private company that was created by Congress in 1970, with the mission of providing efficient and effective intercity passenger mobility. All right. So Amtrak as such is a federally chartered corporation. meaning that it's a private corporation that was chartered by the federal government. And as such, the federal government is still up to today the major stockholder of the company. And then you have a board of directors that is appointed by the President of the United States. And then the company operates as a private company, but still with significant, significant financial assistance from the federal government, especially when it comes to long-term investments and building up the infrastructure and investing in rolling stock. All right. So as a company, we have a national footprint. So we operate all across the continental United States. And I think our tracks and services extend in 48 out of the 50 US states. All right. So if you look at the service we provide, it can be broken down into 3 sub-services. Starting from the bottom here, we have the Northeast Corridor Service, which focuses really on the Northeast region of the United States, from Boston, New York, and Washington, D.C., where, we own mainly the infrastructure there and operate fast transportation service between Washington and Boston, and that's where you will find, for example, the Acela train service, which is the only high-speed train service in the continental United States. So that's essentially 1/3 of our service. The next third of our service is long distance service, which has maybe about 5 million trips a year. And that concentrates about 14% of the total annual ridership of Amtrak, where we have 15 long distance routes that cross very long distances. For example, a train that goes from Seattle, for example, all the way to Chicago, right? So trains that cross really the United States from the east to the west or from the north to the south, right? So that's the long distance service. And then another important part of our business is what we call state supported services. And in fact, this is where we have the most trips that we run on a daily basis, about 15 million trips annually. And some of them are very large. So for example, there are 5 state-supported routes that operate more than 1 million trips a year. And these are specific contracts that we have with state governments, where a certain state wants medium distance rail service, and that state works with Amtrak so that Amtrak operates the service for the state. And an example for that exists in the Oklahoma region. I don't know if you've heard of the Heartland Flyer, which has daily trips between Oklahoma City and Fort Worth, Texas, right? And I was looking at it. There is a stop in Norman. So next time if I ever have a chance to visit there, I will try to take the Heartland Flyer to come visit you guys. So that's in a nutshell what our services look like: Northeast Corridor, long distance service, and state supported. And on a daily basis, we have hundreds of trains running every day across the nation. So as I said, we are 50 years old. And if you look at the services that we're running, some of them are actually over 100 years, because as I said, the company was created 50 years ago, but the services underlying the company have existed within other corporations that also had freight railroad. So it's a very sort of established business that's been around for a long time. You know, if you watch old Western movies, you find that railroad is intimately tied with the history of the United States, and how the westernmost parts of the country became inhabited, and how it was a key driver to business. So we are all business, but we are also a business that is, expanding and trying to project into the future. One of those examples is in 2021, we will open our new main train station in New York City called the Moynihan Train Hall. So if you ever go to New York, it's right there in Manhattan, very beautiful building, and it will be the basis for our service in the northeast part of the United States. Another key innovation that we'll be bringing very soon is, the new generation of our high-speed fleet. So the new generation of the Acela train, which we hope to introduce, in 2021. And we actually have 2 of these trains already running tests across the country right now, testing for speed and safety and so on. So we do not have this service outside of the Northeast, but that's a hope we have for the future, to expand these types of services elsewhere. So if you are in New York or Washington, this will be cool for you to test, trying to bring, the type of high quality, high speed rail service that you find in Western Europe and in Asia, Japan, China, for example, trying to bring that type of high-speed train experience in the United States. So these are some of those the things that we look forward to going forward. All right. So Amtrak is a relatively large corporation, and within Amtrak, within the operations division, I lead the team called the Operations Research Team, and the main purpose of that team is to help the company go through these different transformations that I've talked about in an optimal way. So we're building a new train station. We're introducing new high-speed service. We are renewing our fixed infrastructure. How do we do that in the most cost-effective way, and how we do that in the most effective way or efficient way? So using different techniques, mathematical optimization, simulation, data analytics, AI, my team at Amtrak tries to build decision support tools to help the company become ever more effective and efficient in transporting passengers. All right, so that's really the mission of our team, right? So the mission really is making better decisions, right? And these decisions, we want them to be data-driven. Traditionally, the gap between decision and data, which very often is a large gap, without assistance from decision support technology, this depends heavily on human intuition. So you have people who've been around for a long time, who are very experienced and very knowledgeable about the technology, about the business. And, these executives, interpret the data, interpret the trends, and using their human intuition and skill, bridge the gap between data and decision. And our role is to help in multiple ways. For example, in descriptive analytics, working on multiple dashboards using technology like Tableau and so on to capture data from various areas in the company and building summaries and reports that make the job of those decision makers easier. So, and that's in the area of descriptive analytics that answers the question really, what's the case? What's the current state of the business? What are our performance indicators? What's the average on-time performance of our trains? What's the ridership level, how ridership changes on a daily basis, and so on. So that's one of the areas in which we work, which is capturing data and summarizing it to make it easily interpretable by decision makers. Another area that we work in is predictive analytics, and that is sort of projecting ourselves into the future and saying, okay, if we were to introduce another train during this time of the day, what impact would it have on ridership, for example? So can we forecast transportation demand based on price changes? Or, what would be the average boarding time if we change the boarding process at the new Moynihan train station, for example? So those are questions that deal with the future that we're trying to predict, and that's also an active area of work for us, predictive analytics. And then the other area, the other questions that we answer is prescriptive analytics, which has to do with optimization very often. And that is, for example, how do we reach a desired state? So what's the best way that we can organize our rolling stock turn plans to minimize the overall cost of our labor, for example? Because as you know, labor is a very big cost contributor in transportation. Each train needs an engineer who drives the train, needs a conductor who deals with safety and who communicates with passengers. Also on board services, people who sell food, for example, on the trains, cleaners, for example, who make sure, especially in the COVID context, that all surfaces are cleaned. How do we optimize the assignment of people to each of those tasks in a way that guarantees safety, that people have the appropriate amount of rest, but also guarantees cost effectiveness, that we manage to do all of that respecting all laws and standards, but at the cheapest or at the lowest possible cost to guarantee the perennity of the company. So this is, in a nutshell, what we try to do. We try to bridge this gap between data and decision, and we also try to add value to the decision-making process, because none of what we do is really new. All of this is already in the minds of decision makers in the company, but we're trying to reach these decisions faster, in a more reliable way, in a more traceable way, and so on and so forth. So in a nutshell, really, our work, we perceive it as a process for adding value to intellectual capital and data stores that already pre-exist in the company. And our aim for that is to accelerate and maximize decision power. All right. So that's really what we do. So in terms of the group, it's really not a very big group. So it fluctuates, but maybe at maximum 10 people will be involved in this whole OR process, and people working in this department generally are Ph.D. graduates from industrial engineering program, applied mathematics programs, computer science programs from across the country. And we're based in Washington, D.C., but we support decision-making initiatives across the country. So,
Dr. Seck,
sorry?
if possible, if possible, I have a question.
Yes, please.
If you go back to the previous slide, please.
Yes.
So here, I understand that the goal here is to augment the decision making, right, or the decision maker with a set of tools. I cannot see in the in the first or after the prescriptive analytics.
Yeah.
Do we still have like bit of human intuition applied here? Because the model in the first row, it seemed that they were taking the human intuition out of the equation. Is there still like a human intuition?
That's actually an excellent question. Is there still space for human intuition once you apply these analytical techniques? And I think actually human intuition remains central, right? So our models here generally will generate alternatives, or will generate key performance indicators or courses of action. But in the very end, you know, it is the superintendent of a particular work zone, or, you know, the chief operating officer, or, you know, the vice president of transportation who will make the final decision. So these models are decision support. They're not decision-making models, and they don't automate the decision process. So yeah, ultimately, the competence and the responsibility still remain within the human actor. And I think maybe that will change one day, but that's not about to change anytime soon. So we are a force of proposition, advice, but in the very end, you know, it's an engineer who's been in the company for 10 years with experience who will make the final decision. And it sometimes happens that the optimal solution we propose is put to the side because, you know, our models always make simplifications and might not be trusted in a particular instance. So sometimes the manager still goes with their gut feeling and says, okay, I like what you say with the model, but for now, let me still do it the way I think it should be done. Because, you know, that's a very important question. And something really important to understand when you apply these models in a practical context. And that's actually something that I've had to adapt to, coming from you know, and sort of academic or intellectual tradition, where to me the aim is optimizing something, finding the truth, but actually convincing somebody is more important than the truth of your model itself. So you have to connect to the intuition of the person you're supporting. That's a great point. I don't know if that answers your question, but we can come back to that as well.
Yeah, thank you. And the other thing is are these models are being used in real time? Like if like something happened or some accident happened, are these like the decision maker have real time access to those, so that based like they do as a help for them to make quick decisions, or these something that run maybe on occasional basis?
Also, very good question. So that depends. Let's say some of these models are used in a sort of, let's say, strategic decision-making stage, where, for example, you're asking, you know, what's the appropriate train schedule that would capture the majority of ridership in a certain region, right? So that's not a question you'll be asking daily. That's a question you'll ask maybe once a year or once every couple of years, and you use this model to support that decision. And then sometimes these questions are tactical. For example, you say, how do I staff my train service? How many conductors should I hire next year, for example? So that is something you will run every 6 months. But then there are also questions that are very operational, where you say, so I'm trying to optimize the rolling stock. What physical train should operate what train on the schedule? So for example, I have a train going from Washington to New York. Should I assign it to train set 1 or to train set 2, right? So that's much closer to operations. And then that's a model you could run daily, for example. And then if there is a disruption, for example, train set 1 has a mechanical failure, you can go back to the model and say, okay, remove this model from the set of possibilities, remove this train set, and then rerun the model. And so most of these models aren't used daily. They're used at the strategic and tactical stage, but we also have some operational models that you can run when a disruption happens to help you figure out what you should do next. So that's an excellent question. These models aren't all used at the same time scale.
Thank you very much for the
Thank you, Dr. Seck. Thank you, Dr. Seck. I think we can move on, and if there is any quick clarification question, we can answer that, but it's better to ask all the questions at the end. Thank you all.
All right,
sorry, Dr. Seck.
All right,
go on.
Thank you. All right, so this actually I could skip because this is really something that you guys know what's the process of model building, right? So, so for example, I'm just trying to explain, how do we get to these models? So a manager comes and says, we don't think that our turn plans are optimal in this region. So a turn plan is what equipment will you use to run what train, okay, what service. So we get a request that tells us, please create a method for fast generation of turn plans in a certain region, all right? So the first step, as always, is a problem definition step. So we closely work with subject matter experts to identify what are the key features of the problem, all right? We build some conceptual models, really similar to what you would do in in an academic research project. So we want to build a turn plan optimizer. What are the inputs? The train schedule is the input. What's the output? The turn plan is the output. What are the factors that affect the decision? What is a minimum turn time? So if a train arrives at a station, how long does it need to stay at that location before it can turn and serve another train, because it needs to be cleaned, and so on. Deadhead times, how long does it take to travel between stations? Maintenance needs at some locations. So, for example, some trains need every week to be stored at a maintenance facility to do some preventive maintenance on them, right? So you need to know that in order to build an optimal turn plan. And then some consist requirements. So for example, train 2250 requires a high-speed train consist, and train 186 only requires a regional train. So once you have the consist requirements, you can know how to assign one train to the other. So we take all of these factors, do some research on how do we model the schedule and so on. So this is the first step, the problem definition stage. Next, it's the formulation stage. So you need to devise an effective mathematical representation for the problem. All right, so for example, using graph theory, you can model the different stations, the different legs of the trips, how the trips are connected to each other, and so on. So this is trying to find a proper mathematical representation. And for example, in the turn plan model, we find that the problem is very similar to an exact set covering problem. So instead of starting from scratch, we will look at the literature for set covering problem formulations and model the problem in that way. And once we have that model formulation, then next is let's build a mathematical, a computer program that solves this mathematical problem. So we'll write, using Gurobi or, Cplex and Python, we'll build a model that solves, we'll build a program that solves that problem. And then we'll test it extensively and present it to, the problem owners for them to verify whether this is a proper solution for the problem. And then once all of this is done, we're not an IT group, so we'll take the solution and now take it to the IT department, and they will build a software program that can now be installed, at our control center, that they can run every time they need to generate a new turn plan. So that's in a nutshell our process, and this is a process that will take 6 months to a year from the problem definition stage to the final implementation, where there is a real piece of software somewhere where somebody's trained to use it on a day-to-day basis, right? So that's really our process. All right, and we have a number of solutions that have been built in that way. The main one of the main solutions we've built in that way is the train crew optimizer. And the goal of that model is, how do we minimize the cost of assigning crews to trains, right? So you have 300 trains running daily. You have different timetables, on-time performance data about these trains, but you also have several rules and laws that control hours of service. So for example, in US law, a transportation employee cannot drive a train for more than 6 hours continuously, right? Because of obvious safety reasons, right? And if you drive for 6 hours, you need to rest for a certain amount of time before you can drive again, all right? And if you arrive at a location at a certain time, you need at least 8 hours of rest before your next service. So there are a number of rules like that, that that regulations have been put in place to guarantee safety. You also have labor agreements where unions have negotiated some rules with the company. And you also have business requirements that, if you get to a certain station, you need to help passengers onboard the train, and then you need to drive the train to the depot so that some mechanical work can be done. So all of those constraints are put together. We build a mathematical model. In this case, it's a mixed integer linear programming model that is later on translated into Java code. And then from there, we generate, on a monthly basis, proposals for the work position of each individual in the country. So each engineer, we tell them, on Monday, you sign up in Washington, you go to New York, you rest for 5 hours, and then you get back on the train in Washington, in New York, to come back to Washington. So, and then we have a plan for each employee daily that is calculated using this mathematical model. And such models have the impact of saving millions of dollars on a yearly basis if you compare it to what was done before, where you had a manual assignment of work. So using this mathematical model guarantees that all the rules and regulations are guaranteed, and that we have a repeatable pattern of work assignment. All right, and some of these I've grayed out because of just going through legal and asking them, is this something that I can put in a presentation? So some of these you cannot really see exactly what the numbers are, but the principle is, writing a mathematical model and optimizing it to, to generate work assignments for people under several constraints. Another work that that we are very actively involved in is simulation, and in particular agent-based and discrete event simulation. And I particularly like this because this is really my area of research. Optimization is something that I do out of necessity, but simulation is really my passion. I feel that this is the most exciting area of work. So we do quite a bit of simulation where we use agent-based models and discrete event models to replicate past events or future situations, test different scenarios. We use mostly general purpose simulation software. In my past work in academia, I preferred to develop models from scratch using, mathematical formalisms and directly programming in Python. That's very difficult to maintain in a corporate context. So we've switched our focus on, instead of developing devs models, we develop any logic models now. And, I still regret not being able to program directly in Python, but that's what it is. And it's been pretty helpful. So some areas that we work in is, for example, what's the impact of track outage? So every once in a while, we have to stop using a particular track because we need to do some track realignment or we need to replace some track segments. And that affects how we can run the trains because it creates congestion. More trains have to run on a limited number of tracks. So we use simulation to schedule those track outages, right? So this is an example of for simulation visualization where we needed to do some construction at Washington Union Station where a few of the tracks had to be put out of service for a few months for major rework. So we simulated the entire station tracks as well as incoming and outgoing traffic and simulated this for 3 months to decide, okay, how should we schedule this work that we need to do on tracks? Should we start working on track 1 and 3 and leaving track 2 available? Or can we do track 1 and 2 at the same time? Or should we only do one at a time because it would have too much of an impact on our on-time performance, right? So basically, you build the infrastructure in the computer and then you put in the train schedule and try to simulate what the impact is. Another type of project we do is, I told you about the Moynihan train hall that will start next year. So this is a brand new train station. So what we did is recreate that station in the computer and ask, okay, imagine Thanksgiving Day, it's a very busy day. How would how would the station look like on Thanksgiving, given the train schedule and how many people we expect to board the train at that time? And what should we do to reduce very long queues, for example? So you see here a very long queue. How should we change the train schedule, or how should we change the physical layout to limit, to limit congestion? And another interesting thing is in the COVID context, for example, these simulations become very useful because you want to create social distancing at the station, and you have reduced ridership, but these simulations can help you figure out whether you can actually run your service while respecting social distancing. and what are the number of instances where people get closer to 3 feet from each other or 6 feet. And simulating this, you can create heat maps that tell you on a daily basis what are the places where people congregate and if you could do something to improve the situation. So these simulations are very, very helpful for what if analysis and predictive analytics. All right. Another area is train performance analytics, where we use historical data to show us, the train departs at this location and arrives at this location. How does delay accumulate over time? And how could we change recovery time between two stations to make sure that people arrive at their destination at the time that we promised them? All right. So on a train route, maybe it takes 2 hours to drive from Washington to New York with the train, but we will schedule the trip for 3 hours, and we will put what we call recovery time at multiple spaces, so that if the train is late, we have some buffer in between so that the train can catch up its delay. So one optimization question is, what's the optimal assignment of that recovery time based on how many passengers are riding the train, because you want passengers to arrive on time. So this is something we do. So we have some tools that tell us, at every station, if you keep the recovery time in this way, what's the percentage of people who are on time? That's the green people. And what's the percentage of people who will be late? That would be the orange part here. And by moving around the recovery time, you can make sure that by the time the train arrives at its final destination, the majority of people are in the green category and not in the orange category. So that's also some optimization that we do. All right. Another thing we do is using machine learning to do some causal analysis on the root causes of delay. So let's say if a train is delayed by 30 minutes on a given day, what are the different contributing factors to that delay? Okay, so some of it is passenger train interference. That means there is another train that arrives at an intersection and the second train has to wait behind it before it can start going again, So that's passenger train interaction. You have freight train interaction, which is that our train is delayed and waiting behind a freight train. You have positive train control failures. You have a number of different root causes that lead to a train being late. So part of what we do is on a monthly basis collecting on-time performance of all our trains and doing, some nonlinear regression using deep learning and so on to categorize the different categories of train delay. And that allows us to tell managers, if you want to improve the performance of this train, the best way you can do it is by changing the schedule, or the best way you can do it is by improving the onboarding of passengers at this location, or the best way you can do it is to negotiate with another train company to tell them that you delayed us for 10 minutes last week. Could you make sure that next time we arrive there, you can let us go first, for example, if it's a freight train, right? So doing this analytics allows us to understand exactly what are the root causes of the different delays, and then we can use that information to have a conversation with the different parties that allows us to improve the service. And as you can see here with these bar charts, from one train service to another, the root cause can be very different, right? So sometimes it's really just the tracks are frozen, right? Because it's in the winter. So there's nobody you can blame for that. Sometimes it's root causes like, it's in the fall, leaves have fallen, trains run on the leaves, it creates a slippery surface, so the train cannot go as fast as it wants to go. So there are millions of possible causes why trains get late. And doing this analysis allows you to find what are the key root causes, and it also allows you to justify your investments. So if there is a root cause that is only responsible for 2% of the delays, is it reasonable to spend $2 million in an improvement initiative? So this also allows you to know how to spend optimally to achieve the greater good for our customers. We also do some clustering work, for example. So on a monthly basis, we take all our trains and we use clustering algorithms to categorize them into groups. So in terms of punctuality and reliability. So we have some trains that are very punctual and very reliable. So these are our best in class trains. And you have some trains that are, let's say they are punctual, but they are not very reliable. So most days they're on time. So their average delay time is not very high, but once in a week they get late by a lot. So this allows us to categorize the trains and also to communicate to the local managers and say, okay, we've observed that, train number 5 left the group of good students and is part of the ugly trains now. What happened, right? How come this train is not operating well anymore? What can we do to improve the situation, and so on and so forth. So basically because if you don't have this type of analytics, it's very hard for managers who are in the day-to-day business to to be able to detect these trends and take the appropriate measures. So using very simple models like this, we cluster these trains and send monthly messages to the local managers and say, okay, congratulations, all your trains are in cluster 1, good job. Or, well, you should be careful because one of your trains is now in cluster 4. And cluster 4 is, trains that are reliably late. So these are the worst trains, in fact. So they're very reliable, but it means that they are reliable in being late all the time. So this is a train that every day it's late by 30 minutes. That's not good. So it's reliable, but it's not punctual, right? So no manager wants their train to be here for 2 or 3 months in a row, because then somebody will have to talk to them. So these are ways in which analytics can help with the management of a very complex system. So these are not very complicated models, right? These are standard clustering models, using PageRank or very simple clustering tools, but they allow us to minimize the complexity and have very clear communication with managers. Also using let's say nonlinear regression techniques, we are able to, for example, identify what are the circumstances that lead to train delay, right? So if a train is late, we can explain why it became late, and we can decide, what branch of this tree is more relevant for investment. So this is very similar to actually this study here. It is another way for us to look at an individual train and try to understand what explains its performance and give insight to the business leaders so that they can go ahead and take the appropriate measures. All right. So I've tried to show just a set of the different tools that we use, and just looking at where we are as a group. I feel that we are very good at descriptive and predictive analytics, using dashboards, Tableau, using simulation, correlation analytics, and so on. And we're getting very good at using machine learning to explain sources of failure. I think areas that we have to become better at is cognitive analytics, trying to automate low-level decisions. So having real-time monitoring, having a digital twin of our train service and giving real-time advice to people in our control centers to say, okay, at this point in time, let train one go first, because if you don't, you will propagate some delay. So having some real-time intelligence, doing some real-time causal inference, doing anticipatory control. So being able to predict the future and take measures that can prevent, disruptions. We're very good at analyzing the root cause of disruptions and reacting. I think the next step for us is to become more proactive in how we use data. And we have pilot projects there that we're working on. And hopefully in a couple of years, if I come back to give a talk, I'll be able to show some nice things, some nice progress we've done in the area of cognitive analytics. So that's in a nutshell my presentation. That leaves us maybe about half an hour, and we can have an open conversation on anything I've said or things that I've not mentioned that you may be curious about. Thank you.
Thank you, Dr. Seck. It's a very interesting presentation, and it has almost everything from the big picture that what you are dealing with in AMTRAK and what are the models or the approaches that you are using, and after giving a clear problem statement and some really insightful examples of that. So now we are open for the questions, comments, feedback.
I have a question. Previously, I was working on a project related to Honeywell. It was all about minimizing the delay time in a production, in a manufacturing. Now I'm working on a project related to measuring the economic impact of COVID in the economic system, considering the trade between states. So my question here for you, which can help to my project as well, is that what was the most challenging issue for considering the impact of COVID in your models? For example, uncertain demand or workforce loss. And the second part is how you solved or address that issues.
So Layli has not changed in asking always the most difficult questions, I've noticed.
Because I know that you can answer them.
So I'm not sure, we're still struggling with, the impact of COVID at Amtrak. And it has really a tremendous impact where at the worst point of the crisis, I think 95% of our revenue was gone. All right. And I believe that right now we are inching back up, but we're not yet at 50% of our past revenue at a comparable time, right? Maybe even lower than that. Yeah, so the impact of COVID, I think it's very difficult to answer this in general. But I can reflect on our situation. I feel that during the months of March and April, basically we had to reinvent our whole tool set, because some of the planning models that we were using were based on assumptions that COVID destroyed completely. For example, availability of employees. We started having people infected, and because of quarantine decisions, the availability rate and absenteeism rates of our employees were very different than what we had before. We had dropping demand, but our forecasting models were not useful anymore because they were based on historical assumptions that were not true anymore. So, so our planning models started to fail. Our labor models didn't have the right assumptions. So basically, COVID forced us to rethink our whole analytics arsenal, and we've built more models in the past 3 months than we've worked on in the past 2 years that I'm in the company. So it was really a very dramatic shift. In terms of impact, I feel that we've been pretty good at measuring, what the cost impact has been of COVID to us in terms of both revenue and cost. But I think it's a much simpler problem if you're looking at one company than if you're looking at trade between states and things like that. So, I've said a lot, but I've not really said anything useful to help you. But, we could have, I guess that, we can talk offline maybe to.
Yeah, sure. About the modeling,
Mm-hmm.
partially, I'm interested to know how it impacts the models. Yes, we will talk later. Thank you.
All right. Thank you.
Okay, any other questions?
We have a quick question here about when you are building the model or trying to do some of the classification, it's very necessary to have a data, right?
Indeed.
Based on what you decide, I'm gonna go collect data on this aspect of the train, or that aspect of the operation, or this or that. Sometimes it's maybe simple thing that get forgotten that will have very big influence on the model building. So how did you go about deciding which data to collect?
That's right. So that's again a very good question. So I was giving you this example of, so sometimes some trains are late and you really wonder why, because you don't really know what's really the root cause of that. And it ends up being the case that it's leaves on the track that fall in the, in the autumn, and then that creates slippery conditions, and train drivers are more careful, therefore they get at their destination a bit later than you planned, right? So how do you capture that in a model? Because we have no data point that says leaves falling. I think how you do that is to be very open about what you want to include. So typically when we do these classification models, we start with a very open approach where we include just everything and anything, regardless of whether we think it is relevant to the model. And then we use some, techniques like, principal component analysis to do data reduction. So we don't want to tell the model what is relevant. We try to use rigorous data reduction techniques, so using statistics to guide you towards what parameters have an impact, and then keeping the human expert in the loop. Because during your analysis, you can do a time series analysis and find that you have a problem between, let's say, between March and April, or let's say in June, there is a problem in train performance, but nothing in the data tells you why. Nothing gives you an explanation. But then when you go and talk to the people in the control centers, they'll tell you, well, we have some speed reductions that we implement when temperature is above, 100 degrees, because you know that when it's very hot, you have a dilation of, the steel on the tracks. And, we have some speed orders that are effected during that time. So we discover that there is some sort of correlation between temperature and delay. We don't know why, but if you speak to the right people in the company, they'll tell you, well, you have identified this correlation between temperature and delay. The root cause is because when the temperature exceeds this level, we have a speed reduction for safety reasons. So I think you include everything, and you don't do your analysis in isolation. You talk to people, because basically engineers have thousands of correlation models that are already solved in their minds. So you have to pick their brains, and very often they will solve a problem that you spend a week trying to solve in the lab. But if you talk to the person, they have a lot of experience, so they can guide you in in your variable selection.
Thank you very much.
Okay, any other questions?
I have a comment and a question.
Okay.
Mamadou, I'm really intrigued by the slide 21 that you've given, because it's a very holistic picture of what, no, slide 21, where you were. Yeah.
Oh, here, yeah.
Yeah. Because it's a very holistic picture of what people need to learn to be able to do things. Starting with the descriptive aspect of the problem, and then coming with the predictive elements, where you use statistical analysis, correlation, scenario planning, forecasting, etc. Then go to the prescriptive form. So and then to the cognitive form. So it's very interesting, because you have description, which is typically in words, and maybe some numbers. Then you do some simulations that give you a feel for what you may be using, system dynamics or what have you, and scenario planning to do some forecasting. And then you go to number crunching, where you have you use optimization, and you say, okay, we assume that the data that we have is perfect, good, therefore the single solution that you get from the optimization problem is fine. And then the one that really intrigues me is cognitive. And you talk about decision automation. That doesn't tie to cognitive. What you're doing is you're taking the human being out of the cognitive loop. Okay.
Right.
So my gut feeling is that perhaps that word is cognitive is not quite right for what you have out there. So I think what you're really looking at here is providing decision support to a human being. And what's happening here is that the computer and the human being are working as a cyborg. So the role of the computer here is to support human decision making. That I accept. So in other words, you're saying the information that is being given through design automation or decision automation, causal inference, digital twins, anticipatory controls, these are things that come because of the numerical model that you have. But the models are not complete and accurate. Therefore, you need the human being. And therefore, what's happening here is not cognitive, but providing decision support to the human being.
I tend to agree with that characterization. I think the cognitive term here is maybe not the best term. I think this is really going towards more cyber physical view, where you have sort of an Internet of Things, real-time sensors, models that are not so much strategic or tactical, but models that are real-time models, and then figuring out, how do you connect that model with a real-time operator to accelerate the decision loop. I think that's really what's
there. What you're talking about is human in the loop.
Indeed, yes. So, yeah, but right now, the human is in the loop all over here. If you look at the decision process as a whole, I feel that what's really different here is really just the time scale, that we're trying to do this in the control center. Because right now, most of our optimizations are helping in the boardroom, right? The optimizations is helping executives and middle managers to do their job better. But where the business is really run is in the cockpit, and in the control room, right? And that's where the quality of the service happens. So if you really want,
so in that case, what you're really talking about is tactical decision making. So what you're looking at here is that when you give the system autonomy, what is the role of the human being? You want to take the human being out of the loop to the extent possible.
Well, yeah. And I would not say it that way, because that would actually lead to big trouble if I went and said that. But indeed, I mean, to the extent possible, if there are things that the machine can do better than the human, we should try to automate those as much as possible. Similar to, in most of the modern cars right now, you have automated braking. So if a danger comes in front of you, the car brakes itself, right? So we don't have full-fledged self-driving car, but maybe we can have automated braking, right? So we want to bring the machine closer to where decisions are made, because sometimes humans make decisions that machines could avoid. If we have an ideal, separation of roles between the machine and the person, while avoiding that the person doesn't sleep on the steering wheel, because we've taken too much control out of him, and the human becomes bored and susceptible to greater danger. So so this is an area that I actually really appreciate your input here, because this is not an area that is well known yet. I don't know what the proper characterization is. So we could say it's tactical decision making. We could say it's automation. But it's basically making our decision support models closer to the action, and capturing reality in real time. So here we capture data, and then at the end of the month we generate metrics. It's too late to solve some problems 1 month later. We would like to have sensors that capture the state of our train set and says, when you get to New York, don't return with the same train set. Replace this train set, because in 3 hours, door number 5 will break down because of predictive maintenance, and we're not there yet. So we will still react to a door not responding and delaying passengers for 2 hours. So how could we get into that sort of real-time decision making, having the machine take more responsibility in places that it's safe, but still keeping the human engaged. So so this is still in flux, but this is definitely where we need to go to, real-time intelligence. So yeah, so I think that the name here might not be the right name, but that's something we will be developing, because that's where we need the most the most progress.
Thank you.
Thank you very much.
Dr. Seck, I have also one follow-up question here, that maybe not here, but automation can take place, for example, where we want to choose a predictive model for like response surface methods, or when we choose a model for forecasting. We have options like, let's say, neural network, clicking, random forest, logistic regression, and etc. So can we have a kind of like automation, or here we like remove some human intelligence here by like creating a set of particular classes of the problems that you are dealing with, and then when you have that problem and you need to do some forecasting, you just use one particular method with your experience, it has higher accuracy, higher effectiveness, reliability in that particular set of problems. How do you see this kind of automation here? Maybe it doesn't like reduce the time that you are like putting in modeling and forecasting part, but it's still real-time decision making without human intelligence.
Without human, yeah. So that's not something we've done. I think that has value. So in some cases, for example, we've seen that, you know, using different, so we have, for example, some thresholds that are defined in the descriptive models that detect, you know, if some level of variation is detected, then we could run a family of models that use different formalisms or different, you know, different algorithms, and then use some sort of voting mechanism from the model outputs to, you know, to drive us towards a certain, you know, decision outcome. So I think that has value. Have you seen that being applied somewhere? Any papers you suggest to us to look further into that?
Yeah, actually, this idea of family of models or ensemble of models. Yeah, we worked on a particular project on engineering design. We created an ensemble of models or family of models for that problem. And in another project, we used decision trees to somehow classify the couple of engineering design problems, about 18 problems, and suggest some predictive models for each of the classes that we created using this decision tree. So this way, we say that if a similar scenario happened in the future, another 18 or another set of problems, we can suggest these particular models, which has this family of models. Yeah,
indeed.
So it's not very comprehensive, but it's at least the kind of like initial work that we.
Yeah, I think that
the ambition is to like make it like automated in the future.
Indeed. Yeah, I think that's very valuable. Yeah, so I'll ask you to share some of that past work, and I'll be very glad to read that and learn from it. Thank you.
Thank you.
Thank you.
Thank you so much. Thank you. I have one comment as well. In here, you when you talk about scenario planning or in the prescriptive part, what if analysis, it reminds me some kind of scenario planning that Royal Dutch Shell company did before the energy crisis in 1978, I think, or to like kind of predict some crisis or some disruptions, disasters. Let's say, for example, if there is any, God forbidden, another COVID 30 in 10 years, is there any particular model that we can like not predict, maybe more project or foresight that in 10 years or 15 years in long term, in a more strategic timeline can happen and get prepared for that, something like that.
That's right. So, and that's the sense in which we use scenario planning. So, for example, COVID took us all by surprise, but I hope that now when we do our annual operating plans or our, you know, strategic vision setting, that, you know, using scenario planning, we can look at, you know, basically looking at, you know, a pessimistic, optimistic, and normal kind of and we're doing this right now, for example, looking at recovery. So we don't know when people will start traveling again, but we need that information to schedule, you know, our personnel training and stuff like that. So using scenario planning, we have, you know, 2021 will be normal, 2021 will be just as bad as this year, or an optimistic plan where 2021 will be where we'll get back 75% of travelers. And then using those three scenarios, we try to figure out what impact it would have on all our decisions. And in the end, we say, okay, we'll use the pessimistic plan, or we'll use the business as usual plan. So that type of scenario planning is very helpful, especially in situations with low data. So that's something we're using.
That's very helpful. Thank you so much. Is there any other comments, questions? If there is no comments and questions, maybe we are ready for the takeaways, closing statements.
All right. So, I mean, it was really a pleasure for me to come and talk to this group. Now I feel why I miss a little bit academia, because in just this hour and a half, you know, you see the critical thinking that is there, and you know, so it was a great pleasure for me. I hope that this has given you sort of a high-level view of how the techniques that we're using in, you know, in research can be very valuable if they're brought to, you know, the commercial, you know, into the commercial world. So all of these are things that are not surprising to you, because you're using these models daily, and even more complex models than this. So in my thinking, really, most of the industry is maybe 5 years behind in terms of actual, you know, modeling ability. But there is a change of mindset too that you have to go through, where the most important is not really actually the truth of the model, but how convincing the model can be. So sometimes I will switch to a simpler model because I feel that what that model says will be more easily digested to the audience. So that's also sort of an aspect to think of, you know, in a transition from when an academic or an ex-academic communicates with, you know, a COO or a CEO. I have an anecdote where I presented a very complex statistical model, and you know, the boss said, you know, if you cannot explain this to me in 5 minutes and I understand it, it's not a good explanation. So the quality of the explanation is not really in how complex it is, but how convincing it is to any audience. So yeah, I hope that it was informative to you, and let's keep the conversation and stay in touch.
It was very helpful. Thank you. Thank you so much, Dr. Seck. It was very helpful. My takeaway is that, you know, all the stuff that we are doing in academia are very valuable and helpful in the industry, and it's very fun that you can verify and validate the models that you create in industry with the real-time data.
Mm-hmm.
And with that, I would like to ask some comments maybe from other students. Maybe we have Wael and Farinaz here as well. ODU.
That's cool. That's really nice. Wael, how are you?
Good. How about you?
Good. So it's so nice to hear you. That's great. How's ODU?
Good. Yeah. Staying at home these days.
Very good. That's safer, right? Yeah. But hopefully everyone is doing well there. Pass my greetings to everyone, whoever you see.
Sure, of course.
Excellent.
It was nice to hear from you. So that reminds me of the old time.
Oh yeah, that's nice. Yeah, the good old days, right? Yeah. Thank you.
Thank you,
Hari?
Dr. Seck.
Thank you, Layli, and hi to Farinaz as well.
Farinaz, do you have anything to say? Roshan, do you have any closing statements, takeaways, comments, feedback?
Thank you, Dr. Seck. I mean, it was very amazing. It gives a very good perspective. Also, I mean, I'm a big fan of trains myself. My grandfather used to work in Indian Railways.
Very
So
nice.
it's been always a pleasure to understand the trains and the business behind it. And it's been a really interesting perspective for me, for sure.
Thank you. Thank you very much. It was a pleasure talking to you.
I mean, final comments?
Yeah, I'd like to thank you all, especially Dr. Seck, for delivering today's presentation. It's amazing, and it just opened a new perspective to look at when you deal with the industry and compare it to the academia side. There is the convincing part of it that we need to learn. Yeah, thank you very much.
Thank you. Thank you very much.
Thank you so much, Dr. Seck.
All right. It was my pleasure, and yeah, we'll talk again soon. Thank you.
Sure, I'll be sending the recording to you, and you can have comments, edits, and then if you are agree, we can post it on our YouTube channel.
Very well. Very well.